Hello, welcome back. We're going to do 4.3 day 1 today.
Hello.
We're both back.
We're back.
Okay, we're going to talk about, what are we going to talk about?
We're going to graph radian and degree angles in standard position. We're going to find reference angles for them. A little bit of review from 4.1 right there. Mostly we're going to identify positive and negative angles. We got this word coterminal. You get to talk about that.
Whatever that is.
And we're going to do some exact values in standard position. I get to do that part.
Yay.
So you're first.
All right, let's get going. Here we go. All right, SOHCAHTOA worked really well for acute angles, little tiny angles in the first quadrant. That's what you spent 4.2 doing, in case you weren't realizing it. All right, what happens if we need angles 90 degrees or larger? Larger?
Big angles.
Bigger ones. All right, what are negative angles and what do we do with those? All right, those are the questions we're going to try to answer in the next couple of slides here. Ready? Okay, so vocabulary. This is what this is all for. This is really all it's for. Okay, standard position has not changed. You place angles in standard position and you can extend the terminal sides past the first quadrant. So if we are in standard position, we always start here and we can now go past the first quadrant to the second quadrant or all the way to the third and fourth quadrants by going all the way around. Okay? So what do we need to remember? Positive angles are measured counterclockwise. Those are the ones we've been doing. Negative angles, what are they?
What if we go the other way?
Those are going the other direction. So a negative angle would start in standard position down the x-axis to the right, but go down and to the left, or counterclockwise, or sorry, clockwise. I have a digital watch. Reference angles are still the acute angles measured back to which axis?
The x-axis.
Always to the x-axis. So if my angle is over here, my reference angle is going to go back to the x-axis, and it's going to be a positive acute angle that gets me from where I ended my terminal side back to the x-axis. All right, coterminal. What does coterminal mean?
Well,
what?
You're my co-worker, and you work with me, so I think it's with terminal.
With terminal? Terminal means end. How about we just say they end at the same place?
Beautiful.
Does that work? All right.
They end with each other.
They end with each other? So here's a 30-degree angle in quadrant 1.
Does that mean I'm with a field?
We're not going there.
Sorry.
All right, a coterminal angle would end up in the same place. Here's a positive coterminal angle. All I'm going to do is go around the circle once and then end up back where I started. I go, and so I've gone all the way around the circle. How many degrees are in a circle?
360.
So if I go 30 and then I go 360 more.
That's 390.
That's 390 degrees. That's a positive coterminal angle, and this board just sucks right there. So let's try this way. Here's a 30-degree angle. A negative coterminal would say go the other way, all the way around to there. Well, if this was 30, there are 360 degrees all the way around, so what did I do to go the other way?
You have to take out, you didn't quite go all the way, so you went 30 less than a whole circle.
So this would be
330?
330, we could subtract.
Why do you make me subtract?
But we went backwards, we went in a negative direction.
Right.
So a negative 330-degree angle, a 390-degree angle, and a 30-degree angle are all coterminal.
So they're basically the same angle.
Basically, they're exactly the same angle.
Okay.
We're just going to keep going in circles.
We just call them different measures, different names.
Different names.
Okay.
It's kind of like a hamster in a wheel. We're going to go round and round and round, but we're not going anywhere else. Okay. Let's try this. How does this work? I have to find and draw one positive and one negative angle that is coterminal with the given angle. So negative 210 degrees. First of all, it's negative. So which way do I go?
Clockwise.
Clockwise, which in my case is
down.
So if I'm here at 0, I'm going to go down 90, 180, and then I got to go 210, which should put me about right here.
Yes.
So that is negative 210 degrees.
Okay.
So let's just label that. It's right there, but that's good enough. All right, different color here. I would like a positive angle that is coterminal.
So can I just go the other way?
So we're going to start back at 0, and we're going to go here.
Okay.
How far is that?
Well, 360 is a whole circle. 210 was going down and around, and this is going up and around, so 360 minus 210.
So 360 minus 210 is 150 degrees. And it's a positive angle. There's one of my answers. Okay, now I would like to go in a negative direction that is also coterminal, but my original angle is also negative. So I can't just go to the 210 mark, negative 210. I have to go all the way around again.
Oh, geez.
I could do it 3 or 4 times if I wanted to, but let's stick with 1.
Okay, 1 is good.
All right, so 1 trip around the circle is going to be negative 360 if I go that direction. I already went negative 210, so I just add them together and I get how much?
Negative 570.
Negative 570 degrees is my negative coterminal angle. All right, well, that's if we have degrees. What about radians? Well, we got 13 pi over 4 here. All right, so we start our radian measurements in a positive direction. This was 0. And this would be pi. That would have been 4 pi over 4.
So 0 is 8 pi over 4.
Okay, so I'm actually going to go back up here and count by 2's because I can't count by 8's.
Okay.
So that's actually going to be 2 pi. And if I wanted to get to 13, that's going to be 2, 4, 6, 8, 10, 12,
and a half.
and then the next one would have been 14, so I'm going to go halfway, and that's going to be 13 pi over 4.
Okay.
Ooh, that was fun.
I'm kind of dizzy.
We went around in a circle a few times. But what makes it easier is to find the actual coterminal angles, because now I can go in the same direction, but I don't have to go all the way around. I can just go straight there. So how far is that? If it was going to be 2, 4, and then this would have been 6 pi over 4.
5 pi over 4.
Halfway between 4 and 6 would be 5 pi over 4 would be one positive coterminal angle.
Okay.
All right, what if I went the other way? Different
Green.
color,
Green.
green. Let's go down or negative angles and go back to that mark. So that was down 2/4, so this is actually going to be negative 2 pi over 4. And then we'd have negative 4 pi over 4. And then negative 6 pi over 4 if you wanted to keep going. But if we go down this way, how many is that?
Negative 3 pi over 4.
That's negative 3 pi over 4. Okay, for those of you that like fractions, this is going to be a piece of cake. Otherwise, just find a nice, easy place to start counting and count all the way around. But pretty much whenever you want a positive coterminal angle, you can add 360 degrees or add 2 pi to your answer, okay? That's one way. That just means you went one more time around. And if you want to go in opposite direction, you just figure out what you're missing from that
Whole circle.
whole circle, okay? So you can do this algebraically. You don't always have to draw pictures. We're going to ask you to draw the pictures just to see if you know how to draw the angles, okay?
We like pictures.
Pictures are fun. All right.
Speaking of pictures, we have a picture here for, what is it, standard position that we need you to fix.
Yeah, you're going to have to fix it.
So we're going to change this one because Mrs. Cofield drew it, and you learned from the last lesson that I make mistakes, so get over it. Okay, we're going to let theta be any angle in standard position, just for ease of drawing here. Go ahead and change this and get rid of all this, okay? And I could get really fancy and erase it if I knew how, but...
No, you can't, because it's locked in place and you can't touch it.
Oh, you're right. Okay, so we're going to draw it in the first quadrant, and we need theta to be our angle in the first quadrant. So this is our little theta right here. Okay, if that's the case, this terminal side of our angle goes through a whole bunch of ordered pairs, dots. We're going to call this one P, which is x, y. X, comma, y. All right, when we do that, r is the distance from the origin, or like the radius of a circle, from the origin to that point. So this is going to be our r. Now, what that just did is we can drop in a perpendicular, okay, and we can go from this point and imagine going straight down, so that to get to that dot, instead of going up r to get to that dot, I could also go over a certain amount. Now, how far am I going to go over if that dot is at x, y?
X.
And how far am I going to go up?
Y.
So now we have a right triangle whose sides are x, y, and r, and whose angle, acute angle, is theta. So far, so good?
Kind of like a reference angle.
It's exactly like a reference angle, only now it's a little triangle instead of a reference angle because we're doing SOHCAHTOA, which is on a right triangle. Okay, so now, keep in mind that if you don't know the radius, you can always go back and find it. Now, Mr. Lecky, where does r equals square root of x squared plus y squared come from?
That looks kind of like the Pythagorean
It's
theorem.
exactly like the Pythagorean theorem. Okay, so basically if you're missing a side, find a Pythagorean theorem with it. Find it with the Pythagorean theorem. Okay, so let's go back and talk about sine and cosine and tangent and all these trig values again. Sine was, go back to SOHCAHTOA, what was sine?
Opposite over hypotenuse.
Okay, so for this little angle, opposite would be,
Y.
and the hypotenuse is
R.
our radius.
R.
Okay, so let's go ahead and do our cosine. Our adjacent side this time would be,
X.
and our,
R.
nice, our radius is r. And our tangent would be opposite
Y.
over adjacent.
X.
Ta-da! Okay, you should be able to fill out the reciprocals, just flip them over.
R over Y.
Very nice.
Can't do it anymore.
Because you're laughing. Okay, so another way to remember our sine, our cosine, and our tangent especially, instead of calling them SOHCAHTOA, we could call them y over r, x over r, and y over x. Or, if we talk about a unit circle and we let the radius be 1, then what happens to our sine of theta?
Well, that'd be y over 1,
So
which
it's
is just y.
That's going to be really, 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 really important later. Did I say really yet? It's really,
Really?
important.
Really?
Okay, really. Cosine of theta.
How about x? Because it's x over 1.
So it's just x. And the tangent of theta then would be?
Well, there's no r in that one, so it's still y over x.
It's
but
still
if,
y over x.
But if y is sine and x is cosine, then tangent is just sine over cosine.
Yes, it is. And that should be something you've already talked about. Oops, if I could spell cosine.
Cosine starts with a C.
Thanks. This board. Did you
I
mention
know.
the board's
The
a mess?
bottom corner of that board is a mess.
Oh.
That's all right. That matches the board.
All right, so tangent, remember, is sine over cosine. Sine is y, cosine is x. Or if you have a radius that's not 1, just remember to divide sine and cosine by the radius amount. Okay, how is this going to look in an example? Let's give it a try. By the way, we're not going to do much of an example with the y, the x, and the y over x today, but we will next class, so that gives you an extra day to, guess what, memorize it.
Yay! I'll put
Okay.
a flashy thing in there later.
Yeah. All right, so we're going to find the 6 trigonomic values, okay, of theta whose terminal side passes through the given point. So this time they're giving us a point instead of an angle. So where is 3, 4?
Well, it's 3 to the right and 4 up.
My hand's in the way. Okay, so 3 to the right and 4 up would be right there, which means I have an angle that starts on the x-axis and goes right there. We don't really care about the angle as much as we do this little magic triangle. Okay, so again, if this point is at 3, 4, then we went, the bottom side of the triangle is the x direction, so it's,
3,
and the vertical side of the triangle.
4.
So how do we find the third side?
Pythagorean theorem.
Okay, so
Or
r
just memorize it.
equals
3, 4, 5
You
always
think
makes
so,
a right
right?
triangle.
3 squared plus 4 squared. Magic, you're going to get 5.
Magic.
Not really magic, it's Pythagorean triple. Okay, so let's go ahead and list our answers, if you will. We need the sine of theta. Now, where is theta again?
Theta is that angle right there that you're
Right
drawing
there,
right now.
that reference angle, okay? Do we know what theta is?
Nope.
Do I need to know what theta is?
Not for this problem.
Not for this problem, because I need the sine of theta, which is the ratio of the sides. So it's opposite, or the y direction,
4,
over the radius.
5.
Okay, ta-da. Cosine. So not really much here is changing. Pretty straightforward.
3/5.
3/5. And tangent.
4/3.
Okay. Don't forget to write the theta, please. You can't just have a tangent without an angle
No
there.
sin, cos, tan.
No sin, cos, tan. Gotta have an angle there. Okay, let's go ahead and do our reciprocals. Reciprocal of sine is the
Cosecant.
cosecant, so the cosecant of theta, just
5/4.
flip it over. The secant of theta,
5/3.
okay, and the cotangent.
3/4.
Okay, so easy enough. That's not the really difficult part to this. By the way, when you go to do this on your homework, you might not have a perfect Pythagorean triple, and you might need to actually have a square root. That's
Kind of
okay.
like they did in 4.2.
Kind of like you did in 4.2.
They didn't like those so much.
And there's no need to rationalize them. You can just leave them the way they are. Shh, don't tell anybody. Okay, so now, what's the difference between letter A and letter B? We've got the ordered pair, 3, 4, and then we have the ordered pair, 3, -4. So the only difference is,
Where it's the points at?
where's the point? So we went to the right and up for letter A, so now we're going to go to the right and
Down.
down. Okay. All right, so basically it's the same triangle,
clone.
and we're just going to copy it. If I push the right button, there we go. It's this same triangle. There it is, 3, 4, 5. The only difference is it's down in the bottom quadrant. So let me flip it over. Flip, up, down. There it is,
Very good.
and it goes right there. Okay? Now my numbers are upside down, but we can fix that because I have a pen. So this is still 3. This is now -4, and this is still a 5. There, isn't that pretty? Okay, what changed? Nothing changed. So really, aren't all my ratios, isn't the same side opposite the angle? Isn't the same side adjacent to the angle? X and Y didn't change, correct?
Nope, we just turned the triangle around.
Okay, so all we're gonna do is cheat. I have this little button right here.
Clone.
Clone it. There's my answers. The only thing that's different is,
Well, we had one side of there was now a -4.
okay, so everywhere I see a 4, I'm gonna put a -4. Which means that the cosine is still positive, but now the sine and the tangent are negative. So what's gonna happen to my reciprocals?
Well, when you flip a fraction over, they don't change signs, so
Yeah, the plus minus doesn't change
they're
there
the same
either.
rule. Everywhere there's a 4, you can put a negative on those.
Where there's a 4, I can put a negative on those. Notice that,
It's almost like cheating.
It's not cheating at all. It's being smart. Work smarter, not harder. Okay? It's the same triangle. The ratios didn't change. So all we care about is the positive or the negative of where our answer is. Okay?
So you're telling me that if the triangle's in a different quadrant than quadrant 1, the signs might be different?
They might be different. As long as it's the 3, 4, that's what's locking in place the size of the triangle. Okay? So, notice, which one stayed the same? The cosine stayed the same, the secant stayed the same in quadrant 4. We're going to talk about that in a minute. If you were in FST, maybe you remember why. Okay. Let's talk about those signs for a second. If I have any dot over here in the first quadrant, I'm going to call it XY. Okay? And I go to do my triangle, my radius, my R will be positive, my X will be positive, my Y will be positive. So when we had the dot in the first quadrant, all of our trig values were positive, correct?
Yes.
All our answers were positive. Okay?
The X, the Y, and the R are all positive.
The X, the Y, and the R. Okay, so what about when we flip this dot down here? Now the dot became X comma negative Y. Which one was the only answer that remained positive?
The cosine.
The cosine. And of course it's reciprocal, which was?
Secant.
Secant. Okay? So cosine and secant stay together. We'll just talk about SOHCAHTOA for a second. All right, what about the other two quadrants? What if I take this dot, x, y, and I'm going to flip it over here now? Now where's my ordered pair?
Negative X, positive Y.
Negative X, positive Y. So anything to do with the X value, back here on this slide, anything to do with an X,
changes signs.
changes signs.
So
the only thing that doesn't change
was the sign in the reciprocal, which was cosecant.
okay, so sine, S-I-N-E, stays positive. Sine stays positive here. Everything else switches. Okay, so we've got a quadrant that has all signs positive. We've got a quadrant that has all cosines positive. You can probably guess where this is going.
I think tangent's positive in the third one.
Tangent is.
Does it work though?
Okay, this is negative X over negative Y. Okay, and we think it's tangent. Now think about this again. A minute ago we reminded you that tangent is not only Y over X, it is also
sine over cosine.
Sine over cosine. So if I take a negative sine and I divide it by a negative cosine,
you get a positive.
I get a positive. Okay? So a shortcut to remember this, remember first of all, this chart only shows me where things are positive. Okay? So the chart shows positives. Positive trig values. That's important. If you memorize the chart, you don't know what it means, that doesn't help. Functions. Okay? So, shortcut to remember, we've got an A in the first quadrant, an S in the second, a T, and a C. So you might remember that as ASTC. You might remember that as all students. Now, the book does take calculus. But since I have the pen and I am not the calculus teacher, I think that all students take classes. I'm also a little bit biased because I never took calculus in high school. Shh, don't talk. Okay, so that's where they're positive. The last thing to remember is that the reciprocals follow SOHCAHTOA. They follow the same rules. So I'm going to write this like this and hope you understand what I just said. In other words, if the sine is positive, then the cosecant is positive because that's its reciprocal. Okay? Again, signs plus and minus are really, really important. So as you're doing these problems on their homework, think about what quadrant you're in and think about whether you should have a positive or a negative on your answer. Always, always go back and check your signs. Okay? All right. We didn't do a specific example of that because we'll cover more of those examples in class. The last thing to remember to think about, if you will, before the next lesson. Now that we know the trig functions when we are given a point, an xy ordered pair, and we can also predict the, oh, it didn't go.
There it goes.
There we go. The sign, whether it's positive or negative, of the trig functions if we know the what?
Quadrant.
The quadrant. If we know where it is on the unit circle or on a circle, we can tell you whether it's going to be positive or negative. So then the last question is, how are we going to find the trig functions when we are actually given an angle? And that's a topic that we will cover in the second half of 4.3.
We gotta wait.
We gotta wait.
All right.
Just a little tease for you. I know, you're at the edge of your seat, right? So
I was.
you should know all students take classes. You should know, what else did we cover? Coterminal.
Coterminal.
And we
Positive
covered,
and negative angles.
yep, and what to do when you have an ordered pair. And that's about it.
That'll
We'll
do
see
it.
you in class.
Bye.
Bye.